Example 5 is a word problem. It involves trigonometry. You can see that the airplane is climbing. It's at a 12-degree angle, so that would be the angle of elevation is what that's called. There's a mountain 12.5 miles away from the airport, and we're trying to find out whether or not the plane is at a high enough angle to clear the mountain. By the picture, it doesn't look like it is. Cross our fingers that he is at a high enough angle. One thing I will mention about this that you need to be paying attention to is units. You'll see that the mountain is 11,088 feet tall. The distance from the airport to the mountain is 12.5 miles. The units don't match. I'm going to use the triangle over there in order to get an answer in miles for what x equals. And then I'm going to use that in order to determine, I'm going to probably change this to miles also to see, how high the plane is going to be at that moment. So, looking at the right triangle existing in this problem, and I'm going to highlight that with some darker lines here so you can clearly pick it out. This is the plane's launch point here. It goes to a right angle here and here. There's our right triangle. We're trying to see if this is a high enough, and again, this isn't drawn to scale. We'll assume that it's not drawn to scale. Okay. The right angle exists over here, and we're using this acute angle over here. So for this acute angle 12, I go across the triangle, that's my opposite side. I go across from the right angle, that's my hypotenuse. And the third side must be the adjacent. Okay, we're dealing with trigonometry, right triangle trigonometry, so I'm going to write my SOHCAHTOA down. Okay. Now in this case, we're trying to find a side in a triangle. We know an angle, we know another side. So what I want you to focus on when you're dealing with trying to find missing pieces in triangles, right triangles specifically, is what do you know, what do you want to know? I know this angle, I know this side, and I want to know this side. Okay? If you know two things and want to find one thing, it's possible to do it. If you only know one thing and you want to find something else, that's not enough information. So, I know an angle, I know a side, I want to know another side, I can work with that problem. All right, as long as I'm in a right triangle. All right. The sides that I'm going to be dealing with help me establish which one of the three trig functions will be helpful. Sometimes it's up to me to pick which one I want to use. Sometimes I'm required to use one of the three. In this case, I'm working with the opposite side, which is here or here, and the adjacent side, which is here or here. You can see that we're only getting one of the two side measures on this one. That's no good. Only one of the two here. This one has both in the same one. So that's the one that's going to help us get the answer. Just like in day one, when we're writing out a trig expression, it's always the trig expression, which in this case is tangent, of an angle, which in this case is 12 degrees, equals fraction bar, and what goes in the fraction bar here is the opposite, which is x, over the adjacent, which is 12.5 miles. Okay, one thing extra I want you to do when you're trying to solve these things, just to get it into a visual picture that you recognize better, I'm going to put my trig value over 1 just to create a proportion. Okay, and it's very obvious here, fraction 1 equals fraction 2. We're supposed to cross multiply to solve. One other thing I want to do, though, is instead of having tangent at 12 degrees, I want to refer to my calculator. And with you guys at home, you might be using your computer for a calculator. You might have your own calculator. Let me actually just go to Google here and do this, because everybody has Google. You just search Google and say, what is the tangent of 12 degrees? And it'll spit out the answer. Now, there's two ways to measure angles. There's radians and degrees. It's very important that it's 12 degrees. If you just say tangent of 12, it might be in radians. So if you're in radians and you say tangent of 12, it's going to give you the wrong answer. So, very important, we have to say degrees. So, tangent 12. Okay, the Google calculator is just perfectly fine. Just make sure you're in degrees, and then you type in what you want, it'll tell you. So I'm going to go 4 decimal places, so 0.2126. Okay, on my calculator here, if I typed in tangent of 12, And you can see it says degrees up there, 0.2126. Same answer, doesn't matter. So 0.2126 is the same as tangent of 12, but 0.2126 is a numerical value it's easier to work with. So I've got my proportional look, 0.2126 over 1 equals x over 12.5. I cross multiply. 1 times x equals 0.2126 times 12.5. Once again, the Google calculator can do multiplication also. Once you get that calculator up, just type in what you need. I'm getting 2.6575. Let's go 2.6. Well, I'll just keep it 2.6575. 2.6575 miles. So if the airplane's flying at an angle of elevation of 12 degrees, as it flies 12.5 miles this direction, it's going to be at an elevation of 2.67 or 6575 miles. Now we just have to figure out if the mountain is shorter than that, because again, that's how high the plane's going to be. We know how tall the mountain is, but they don't have the same unit. So the last thing I want to do here is take my 11,088 feet and we use facts that we know about units, and we know that 1 mile equals 5,280 feet. My goal is to get an answer in miles for the height of the mountain, so I'm going to put 1 mile on top, 5,280 feet on the bottom, unit of foot on top and unit of foot on the bottom cancel. Notice the difference in picture. Fraction 1 equals fraction 2, we cross multiply. Fraction 1 times fraction 2, we're going to cancel and we're going to multiply straight across. So I get 11,088 over 5,280, and the unit left over is miles. So again, we get our calculator out. Again, the Google calculator is capable of doing everything I'm doing on my TI-84 here. I type in 11,088 divided by 5,280, and it tells me it's 2.1 miles. The mountain is 2.1 miles high. The plane will be at a height of 2.6575 miles, which is more than 2.1. So does the plane need to increase this angle of ascent? The answer is no. The plane is fine. All the work is necessary. I don't want to just get a yes, no answer to a question like that. Work it out to get me the reason why it's yes or no. The plane does not need to change its angle of ascent.